This is going to be an introduction to the sorting algorithm that is insertion sort. So this brings up the question of what even is a sorting algorithm. Sorting basically means you're going to take some amount of numbers and rearrange them, some amount of items, doesn't have to be numbers, and rearrange them into order, pretty much what you think it would be. It's an extremely important technique and the most fundamental algorithmic problem. And because once a list is sorted, it becomes much easier to do a number of things, such as searching the list, finding the two closest numbers in a list, finding out if there's a uniqueness, a unique element in a list, along with a range of other things. So being able to sort is very important. A lot of languages have built-in sorting methods, but it's important to understand how to build them yourself. So the basic definition of the insertion sort is a type of sorting algorithm that builds the new array one element at a time. So it's going to take each element and compare it to the one next to it, and items are going to get shifted down as needed until the result is a sorted list. Moving on to the time complexity analysis of insertion sort, the worst case scenario in the big O notation would be O of n squared, along with the average case scenario being O of n squared. Best case scenario would be O of n, meaning that the list is already in order, so you just have to go through each one and confirm that. The worst case scenario happens when the list would be in reverse order, and you end up having to move every single item, but you shift down each time, so you result in O of n squared. Due to the worst case of this algorithm being so poor, O of n squared is not ideal. This type of algorithm is much less efficient than other sorting algorithms, and it's extremely inefficient when it comes to bigger lists. It can result in taking a lot of time to sort a very long list using this method. Now we'll look at an example. So in the numbers that you can see on the screen, the numbers in red, the 3, 6, and the 8, are part of a list that has already been sorted, while the numbers in green are numbers that we have yet to sort. So one by one, we're going to take the 2 and we're going to take the 7 and we're going to insert them into the list to make it sorted. So in this example, we're going to try to insert 2 into this sorted list. So the first thing it's going to do is you're going to compare 2 to the last number in the list, 8. Because 2 is less than 8, 2 is going to replace 8 and 8 is going to get shifted over. Now 2 is in the middle of the list. You're going to compare 2 to the next number, which in this case is the number 6. 2 is still less than the number 6. So 2 and 6 are going to swap places. So 6 is going to essentially get shifted to the right, and 2 is going to replace where 6 was. Now you have 2 to compare with 3. And so 2 is still less than 3, so the same thing is going to happen. You're going to shift 3 down, and you're going to bump 2 over. Then at this point, 2 would be at the start of the list, so you know that there's nothing else to compare it to. But if there was another number, you would keep going until the number to the left of 2 would no longer be greater than, which you'll see when we insert 7 into this list. So now we're going to try and do the same thing with the number 7. So we already have 2 inserted in the list, so our current list is 2, 3, 6, 8, which is sorted. And now we're going to take the number 7 and insert it, and we want to sort it. So the first thing we're going to do is we're going to compare the number 7 to the first number in the list, which is 8. Or last number in the list, but first number we're going to compare it to, which is 8. So 7 is less than 8, meaning that 7 needs to be on the other side of 8. So 8 is going to get shifted down 1, and 7 is going to go where 8 was. Then we're going to compare 7 to 6. 7 is actually greater than 6, so we know that 7 is in its rightful place, because it is greater than the number to its left, but it is less than the number to its right. So now we're going to be looking at another example, but this time we're going to be inserting a number that is not unique to the list that already exists. So we have the current list in red, 1, 3, 5, 7, and then we're going to be inserting that number 3 that is in green. So the first thing we're going to do, just like every other time, is we're going to take the number 3 and we're going to compare it to 7. And 3 is less than 7, so we know that 7 has to get shifted down 1, and 3 is going to go where 7 was. Then we're going to continue, and we're going to compare 3 to the number 5. And again, like we saw before, 3 is less than 5. So 5 is going to get shifted down 1, and 3 is going to replace where 5 was. Now we're comparing 3 with the number 3, and 3 is not less than 3. So 3 is actually going to stay where it is. So numbers that come in, if they are the same, go behind numbers that already existed. Same thing, if we were to bring in another 5, that 5 would get inserted in between the 5 and the 7, not the 3 and the 5. So that wraps up the examples of the sorting algorithm, but they all pretty much go the same way, just like that. So final thoughts on this particular sorting algorithm is that it's not super efficient. If you look at the runtimes, there's definitely faster, more efficient sorting algorithms, but it will get the job done. If you're inserting a number that's going to require you to iterate through the entire array, it's going to take some time, especially if the list is a longer list. But like I said, it will get the job done. And it is also a stable algorithm, meaning, like we just talked about in the last example, that if you were bringing in an element that is a duplicate of something that already exists, the relative order will not change, meaning that if there's an original number, that will come before the new one. And lastly, it is typically done in place. You're going to iterate through the array one by one, and you're going to grow the sorted list behind it. So all in all, it is an array. It is a sorting algorithm that does its job, and you will have a result that is a sorted list, which is all you can ask for given a sorting algorithm.